Cool.
So, hello, welcome all. Welcome to TensorFlow Turkey. At today's meetup, we are talking about conversational AI with transformers and rule-based systems. And we have a cool guest from Rasa, Vincent Warmerdam. Correct me if I
Oh, well done, well
mispronounce
done.
it. Yeah. So we we are co-hosting with Merve Noyan as always. In the last few months, we have focused on conversational AI chatbots with Rasa. So this meetup is built upon these previous events. Previously, we talked about NLP basics, then transformer architecture, different levels and implementations of chatbots. Then we focused on rather we have shown examples chatbots implemented in Rasa. And now we are talking about new rule-based systems from Rasa 2.0. So welcome again, Vincent. Thank you very much for joining us tonight. It's a great pleasure to have you here, and we are quite excited to learn from you.
Okay, that's a lot of nice words.
Could you just introduce yourself? What are you doing at Rasa? What are your responsibilities there?
Sure. So I think I started there 9 months ago, and effectively it's a bit of an experimental role. It didn't really exist before, but Rasa came to the conclusion that if we want to teach people to make very good digital assistants, then it really helps if people understand the components inside of it. Because if you don't understand how the internals work, it's going to be really hard to customize. And there's a whole lot of machine learning stuff happening. So you kind of need a person around that can help out the developer advocacy team and collaborate with the research team. Like there's sort of a person necessary to sit in between those two teams. That's what I am. So I try to support the research team as well as the developer advocacy team. And it's exactly the stuff that sits in the middle of those two teams that I have to figure out and help out with. So that means that I do a lot of meetups like this, but it also means that I get to start a couple of open source projects, for example, to help with the non-English scenario. And that's sort of things that are top of my mind. That's what I do.
Yeah. Before we started broadcasting live, you talk about some non-English tools and data and rather examples. Could you please elaborate more on this?
I'm going to talk me or Merve. You're asking me, right?
Yeah.
So I will talk about that in the talk as well. But one thing that I've noticed is, you have, I don't know, let's say there are 7,000 languages out there. I don't know for sure, but let's say it's 7,000. I've seen that number, so it might be more, but let's say the lower limit is 7,000. It's still weird that about 75% of all research goes to English. Like that feels really, really strange if you think about it. And it makes some sense because English is this really popular language. A lot of people speak it, so you want to make sure that English is well covered. But then, we kind of came to the conclusion at Rasa that it's hard for us to benchmark against all of these different languages because it's hard for people to share data with us. A lot of our clients have proprietary data and we cannot share everything from our users, right? So then I figured, what I'll do instead is I'll just make a bunch of tools available and I'll put that in like a separate contrib library so that it doesn't really make it harder for the engineers to maintain Rasa. And then people can just go ahead and use it. And if it turns out that it's useful, then I can go back to the engineers and I can say, hey, people think that this is super useful. We should maybe move this to Rasa core. Like, that's the idea behind the repository. So if you Google around, there's this repository called Rasa NLU examples. And effectively, it's just me putting tools in there that should allow you to customize your NLU pipeline even more. In particular, there's fast text embeddings and byte pair embeddings. Both have Turkish support. I also have support for the Stanza tokenizer. The nice thing about that tool is it also does tokenization and lemmatization. So if you want to shorten your verbs, so to say, to like the infinitive form, you can also do that for Turkish now, and Rasa can pick that up. So it's these sorts of tools that I'm adding. That's one of the things that I'm doing.
Awesome.
I like to think so, yeah.
Now I'm sharing URL to this Rasa NLU examples, the blog post you wrote.
Yeah. Well,
yeah, I figured out now.
You got to do marketing, so you got to write the first blog post about it. All the tools should be Rasa 2.0 compatible now. So if you have one thing about that, that also means that if you pip install from the repository right now and your assistant is using Rasa 1.10, you have to look at the different version number, because I try to support the most recent version only. That's one caveat that we should be aware of.
Is it only for 2.0?
So there's still all the features that are there now. There is also an archived variant for Rasa 1.10.
Okay.
And I think 1.8 as well. But I am maintaining a sort of all these projects does take time, so I try to limit myself to mainly support the most recent version. So I'm trying to do at least.
So when are we starting? Like, can we start? Because like Vincent told me, he has a lot to tell.
Oh, sure. I mean, it's all relevant questions, so I can start talking as well. I just make sure that Yusuf has questions they're gonna answer.
You also told me you had puns and poetry and other things to tell, and okay. Also spare time for this.
Sure. No, but I do want to emphasize, please, if that's interesting to anyone here, check out the Rasa NLU examples. I'll talk about it in a bit, but I really need everyone, like, I don't know what it's like to make a chatbot in Turkish. That'll be very hard for me because I don't learn languages super quickly. So I need to hear from people if these tools work and if there's something missing that I need to add. Like I need to hear that information. How
many words do you know in Turkish? Like, can you talk?
I just Googled hello, I think, before when Yusuf and I were starting.
I got my merhaba from before the broadcasting.
But no, so
I had an example Turkish pizza bot for the hands-on Rasa. Maybe I can push it to the Rasa GitHub or something, or maybe I can do pull requests to your repository for Turkish examples and stuff.
Yeah, I'm also developing a personal chatbot like Yusuf bot to answer questions in behalf of
He's made a chatbot of himself.
Yeah.
Okay.
So I can push it as well.
Okay. Let's talk about that in a bit. And what I'll do now is I'll just start talking about this topic because I think there's people watching now. And I think I can start doing some demos as well.
I can add your screen to stream, and you can just start with your talk.
Sweet. So, hi everyone. I'm going to be talking about how to be transforming rules into labels, and you might notice that there are 3 words underlined, and there's a couple of puns here, but everything's going to come back together at the end of the talk. In general, there's 3 parts to this talk, and there's 3 separate points that I would like to make. But before I can jump into natural language processing, I think it's relatively important that we start talking about how people might do data science. And we're going to take a step back from natural language processing, and we're just going to think about, okay, let's pretend that I'm World of Warcraft, and I have a data science department. there has to be a data science department at World of Warcraft. Like, it's so much data there. There has to be a data science department.
That's called Blizzard.
Yes. At Blizzard headquarters, there's a basement somewhere where people are really doing number crunching to figure out who has the best orc or something, right? Like, I don't play the video game. I don't want to make fun of it, but people are taking these numbers serious. But I think the main thing that they're calculating most of the time is the question of who will keep playing and who will churn. From everyone who's playing the video game, you would kind of like to know, which people are maybe considering stop playing this video game, because maybe we need to give them like a boost or like some sort of other thing that keeps them playing. Well, it's kind of a relevant question to the organization. So one thing you might want to be doing is you might want to think of some sort of data science pipeline thing where you can say, hey, marketing department, here's the list of people that we think are going to be quitting within a month or something like that. That's something you could do. Now, there's two ways of going about it. You could say, let's take all the data we have and just give that to a deep learning thing, put an ensemble around and let all the tensors flow, buy 12 GPUs, and then we've solved the problem. But another thing that you can also do, and I'm making fun of deep learning for just a moment, but one thing that I hope that you might think is reasonable is you might also just think about the problem. And if you think about the problem, you can also just write down this one if statement that says, if there's a player playing the video game at like 12 o'clock New Year's Eve, like bang midnight, Happy New Year, you're playing World of Warcraft, then I don't need a machine learning algorithm to tell me that you're probably going to keep playing. You're probably someone who's really invested in the video game, and you don't need a deep learning machine learning method to acknowledge this. And if I were building a system...
I didn't think, by the way, if any player was playing the video game at New Year's Eve, odds that this person is very invested in this game and won't stop playing,
So the thing is, there's a data set on Kaggle that you can actually play with that shows you this.
By the way, I had like this ex-boyfriend that literally played World of Warcraft in the New Year's Eve, and he churned years after, not that time, but like years after.
So my mental model makes sense. That's the only thing I kind of want to say here. But I hope, again, this is a bit of a silly example, but I hope at least that I'm able to convince you to some extent, hey, this is actually a pretty okay rule. And then maybe if we're making a machine learning pipeline, maybe it just makes sense that we say, you know what, we have data coming in, but before that we actually give it to the big machine learning model, how about we just say, look, if you're a heavy user, then you don't have to give it to the machine learning model. It might just be possible that we come up with a rule that, not for the whole population, but for a subset of the population, is just going to be very, very accurate. And if you think about a lot of systems that actually do go to production, it's actually not uncommon that there's a rule around it. Like usually you don't say TensorFlow push to production and that's it. Very commonly, business people like to have some sort of a guarantee around the algorithm that you've designed. So that made me wonder a couple of months ago, why isn't this part of scikit-learn? Why aren't we, or part of TensorFlow? Like, why do we have to build the model and then add these rules? It might be nice to just say, no, these rules are part of the model. Let's think of a different example.
If you are like not in like deep learning, maybe like in deep learning as well, but it's mostly decision tree based algorithms that have like rules, like the model itself is a huge rule, like rules and everything.
And you're right, but there's one core difference. This rule did not come about by fitting or training. This rule came about because some person said, well, I've got domain knowledge.
Yeah.
And that is a core difference. And one nice benefit of this is, even if I don't have data, I can totally do this. And we'll see in a bit that we actually have situations where we don't have any data, where we can't trust this model.
Yeah, even if the deep learning model itself is a large rule set, it is quite a black box, and we can hardly explain it to non-deep learning developers, practitioners, and other end users.
I think so. There's merits to a deep learning algorithm. Accuracy numbers don't lie. There's a reason why people like it. But if I think about all the properties I like to have in a model, accuracy is not the only one. I kind of like it if I can maybe do something with these rules as well. But let's consider one extra example, because this one will bring the point home as well. Let's now say that we work for Blizzard and World of Warcraft. Let's say now we're working for a financial institution, maybe a bank, maybe, let's say, a tax department, and we're interested in fraud. Also here, if I start thinking, if I actually were to design a system here, it would probably look something like this, where I have my data, and if the data set says that you're a child and your income is way above median income, someone needs to check that out. Like, children aren't supposed to earn that much money in general, right? That feels like an odd scenario. If you are a person that has 10 bank accounts, same thing. Like, we have to check that out. Like, that should not pass the system. We can write business rules for that. For all of these cases, these are pretty clear-cut cases, right? And it's not a nested tree. It's just saying if this, if not, then pass. If not, then pass. But we could maybe design a system in such a way that we have all the clear-cut cases first, and if none of those things apply, then we do the deep learning model or the whatever model you like. But maybe it's a clever way of dealing with a lot of literally risk. It might be nice to say, no, the hard cases that we cannot have handled by a human, those are going to be guided by a machine learning algorithm.
Makes a lot of sense.
It does, doesn't it? But it's not how people teach machine learning. That's something that I've actually started finding a little bit weird. And I get it. I mean, it's quite, these machine learning models, they're a mathematical discipline for a large part, but practice of it usually does involve a step like this. That's an observation that I have gained over the last couple of years. And one thing that's really cool about these rules is that you can also use machine learning algorithms as part of these rules. So one thing that I'm afraid of at all times when I deploy something is the notion of artificial stupidity. That's the main thing that I typically worry about. Oh dear, I put the wrong image in here, so I'm gonna have to draw. So let's say that you, whoops.
Take your time.
Yep. So let's say I've got a new data set X coming in. And let's say that eventually it needs to go to a classification algorithm. What do we do if X is an outlier? The problem with X being an outlier in production is that, by definition, our classifier probably doesn't know how to deal with it. It might be making a completely wrong decision because it's never really seen something like this before. So it really would make sense to say, well, if there's an outlier here, well, then we trigger a fallback scenario. Let's say fallback 1, some sort of fallback. And then we can say, well, it might still not be an outlier, but if the probability value that we have for a class, for the highest class, let's say, if that's still less than 0.7, right, 70%, if we're not above that, then we can also say, well, the model's not certain, which it's still then not automated. Only when it passes these two stages, then do we actually automate the prediction, and we actually automate it. And I hope that we can see these, like the shape of the rule-based system here. That's kind of interesting. It's really a straight line with one branch at the time that we're passing through. And the nice elegance about this is also the thing that makes it relatively simple. One thing that people didn't really like about rule-based system in the 90s, like they got really complex. Like you had these massive trees that you had to deal with at some point, and those are really hard to reason about. But if you just limit yourself to a certain type of tree, then you can do a lot of good by just adding some domain knowledge in between here. You can add a lot of safety that protects you against this, what I will call artificial stupidity. There's these things that could go wrong in production that you just want to prevent. So I really took a step back when I started thinking about these topics about a year ago, because if you think about the historical aspect of it, I mean, I think back in the old days, if I can say it that way, we used to take our data and we would apply our rules, and that will give us our labels. And nowadays we do it the other way around. We say, no, here's our data and our labels. We put that in the ML soup, so to say, and then we have our rules, and then we can automate all of this. Is something we can totally automate. That's great. And don't want to deny that there's definitely like benefits to this, right? Like the accuracy numbers tend to be way better and the automation is just good. But it might also be a good time to say, well, maybe in this transition at large, we should also admit that we didn't just gain stuff. There's also things that could go wrong. It might be the case that this machine learning algorithm is picking up a pattern that we don't like. And especially when I think of themes like fairness, I literally think it's fair that we think, well, maybe what we should do is we should learn to combine the two again. We shouldn't be too afraid of rule-based systems because as humans, we can apply natural intelligence and come up with proper rules. I don't want to suggest that all rules that we come up with are good, but I do want to suggest that maybe we have been given these rules like a bad time that, secretly we still like them because they're very useful in production maybe. So, whenever I think about these things, and at some point you realize like, hey, yeah, something needs to happen here, that's usually the time that I start an open source package. So the first thing that I would like to show is just a couple of things. Like if you think about rule-based systems, what things you can do in scikit-learn that might be beneficial. After that, I want to show you some things that you might be able to do in NLP using rules, in particular, things that you can do with Rasa 2.0. And after that, I'm going to show you a really cool demo that's really just combining transformers and rule-based systems in one lovely little package. But I hope we're kind of interested in this and excited about it. I'm going to switch to a Jupyter Notebook now, but this might be a really good time for questions too.
Yeah. If you have questions, please feel free to ask them, and I will extend them to Vincent.
I kind of have a question.
Sure.
Like, do companies tend to adopt like hybrid systems with machine learning and rule-based, or is it just Rasa nowadays that adopt?
So I think if I'm being completely honest, I'm really sure it's not just Rasa. There'll be, for example, if you're in the finance industry, there's laws, right? And your machine learning algorithm has to follow the law, period. So it makes a lot of sense that in any financial institution, there has to be a rule somewhere, again, because law. I don't see a way around it, that you can guarantee something like that with a machine learning algorithm. So I do want to say one thing that's interesting about this. I was developing this particular package independently of my colleague who was doing the rule-based system in Rasa. It's just that at some point we met for lunch and we came to the conclusion that we were both working on the same thing. It's just that he was doing it for Rasa and I was doing it for scikit-learn in a way. But we did it for a very similar motivation. It's easy to reason about if you just introduce a couple of rules around the larger machine learning system. So
the screenshot, like the Jupyter Notebook, the package HUlearn, what do you call it?
You know how in scikit-learn you import, so if you want to import scikit-learn, you install scikit-learn, scikit-learn, that's learn. This is what you pip install, but you import sklearn. So I'm following the same weird standard. My package is called human-learn.
Oh, that's the awesome data drawing thing. Like,
people haven't seen it yet. People haven't seen it yet.
I'm not spoiling anything. Okay.
But yes, it's that. Anyway, what I've got here is a Jupyter Notebook, and I'm going to give a quick overview of what the library can do. But the important thing is not so much the syntax. The important thing is more the mental, like how do we build models, and is there something to gain here? So I'm doing something that's really unoriginal. I have the Load Titanic dataset, the one from Kaggle, where you can predict whether or not somebody survived the Titanic disaster. You know whether or not someone survived. You know what class they were in. You have a name. You have a gender, an age, how much people paid, the number of siblings, a bunch of information that you have. Now, what you could do is you could put this in the random forest, right? You could totally do that. But let's pretend that this might be one of those moments where a business person actually has like an insight, like, hey, I think you can make the prediction using just one column. If that were the case, I think what I would do is I would say, well, I can imagine that if you paid more for your tickets, you're probably more wealthy, you're probably closer to a well-protected deck, and therefore, you probably survived. Just simple business rule. And even if this idea is not the most accurate one, I do hope you would agree, benchmarking it isn't a bad idea. If I can benchmark my domain knowledge, then at least I have a number to beat with my machine learning model. And that's nice to have as well. And that's actually one of the main goals of the library. The question is, though, like, how do you define a classifier in scikit-learn that does exactly this? Because, in Python, it's much easier to write this down as a function instead of a classifier. So what HumanLearn has is a thing called a function classifier. Now, the way it works, literally, is you just define a function. So I've got a function here called fair-based. The way the function works is it accepts a data frame as its first argument, and then any arguments that follow are, let's say, hyperparameters that we'd like to optimize. In this particular case, I can just say, look, if you paid more than a certain threshold, then you've survived. And if it's not the case, then you didn't. Then the way that this function classifier works is you can just say, look, I'm declaring a scikit-learn classifier, and I'm giving it the function that I just defined, and I'm also giving it this keyword argument, namely, that's the hyperparameter that I might want to tune. By doing this...
Is it like you are defining a threshold for the fares?
Yes.
Like people who paid over $10 will survive, like something like that, right? Yeah.
That's exactly.
So just wanted to clarify for people, because instead of fancy wording with hyperparameter tuning and everything, it's just
so you can call this hyperparameter tuning, you can call it a big for loop, both of which to me are accurate enough. But the main feature of this is, and again, I like the question because I do hope that this is a very sobering experience. You can also do a grid search, or you can also tune hyperparameters of a Python function. It's just that this Python function is now also something that scikit-learn can interpret. So the nice thing about this is I'm assuming people here have seen a grid search happen before, and in scikit-learn you have this grid search. What you can do is you can just say, well, I have my model over here. I've got this threshold parameter that I would like to grid search over, and you can totally do that now. So the idea here is that I'm trying to make it as easy as possible for you to put your human knowledge in as a benchmark. That's the idea. Because if it turns out that this simple formula is as accurate as a random forest, that tells me something about how complex I need my model to be. And the nice thing, we'll not go into details here, but you can see if you do the full grid search, if you change the parameter for the threshold, there's some point where the accuracy is highest. You've got your precision going up, and you've got your recall going down. That kind of makes sense because on this side of the spectrum, people pay way more and way more. There's not a whole lot of people who paid this much money for a ticket at some point. So the fact that you get less and less people with the one classified makes sense. So that's why the recall over here is super low. And, we're being more and more picky as we get over here. So that means that the precision, gets kind of high. And you can kind of see that if we just have this one function, we kind of already have a model that's 70% accurate. If you then do your random forest trick and you get a model that's 80% accurate, but it's really, really complex, then I hope that this gives you a qualitative feel of, hey, which models might we prefer? And that's something that I'm hoping to achieve with this library, to just make these kinds of conversations easier. But that's not all, because this function classifier can also easily be used to make systems like what I just drew before. If you want to detect an outlier first, and then you want to check, hey, is my model very accurate? Well, if you can define that logic in a function, you're done. That's it. That's a nice thing about functions. You can just declare them quite easily. So what I'm doing here inside of this make decision function is I'm saying, well, up front, I have an outlier detection system and I have a classifier. And let's just assume that they're scikit-learn compatible just to make this easy. What I'm doing is I'm saying, look, let's first take the classifier and let's just make all the predictions that we can. And then we can say, well, we can calculate the probability value that's attached. But if the probability value, if the maximum probability that we see, if that's less than a certain threshold, then let's change the predictions that we have over here into there's doubt and here's fallback. We're saying, well, overwrite that classification. And below here, I'm doing something that's very similar, but I'm doing it with an outlier detection mechanism. And lo and behold, if I put this function into this function classifier, I suddenly created a very nice way for me to sort of have, I won't predict this or I won't predict this into my pipeline. And that's kind of nice. If there are things that I'm specifically afraid of for my specific use case, I now kind of have this nice little handle that allows me to protect myself against that. And something that's really cool about this too, some of these rules, again, you can define without seeing any data yet. So if you are building a use case and you don't have data yet, that's not you can still go forward and do progress on a use case, which is very, very nice. And now comes the part where you were excited about, I think. So I think making good rules, part of that is using functions, right? So if I say, well, here's your classifier, you can do the same thing with a regressor, you can do the same thing with outlier detector. These are good features. However, you can also wonder, well, maybe it's not necessarily the function that's the problem. Because very often you can look at like a diagram like this, and you can kind of say, well, it's hard to write a function for this. But if I could just draw the algorithm here, I wouldn't need machine learning. You can't always do that. But in this case, I've got a data set with 4 columns. And what I can do is I can just double click, click, click. And I can just say, well, I think this is where most of the red dots are. I can do the same thing for blue. I can sort of draw these polygons. All right. Double click. Nice. And here's 2 other columns. I'll just color in the blue one here. All right. And the nice thing about how this works is because these are polygons, computer science gives us these point-in-poly algorithms. So I can say if a new data point comes in, if it's outside or inside of a polygon. If it's outside of a polygon, I might be able to do something like, hey, that might be an outlier. And if it's inside of a polygon, I can kind of do this weighted mean to figure out, hey, are you in more blue polygons or in more red ones? And what I can then do is I can say, well, I have this drawn data in this interactive classifier. I think if I do .data, that's a method. But you can see the JSON information of everything I just drew. So these are all the coordinates that I just drew, plus some extra information. I can pass that data into something known as a interactive classifier. It's the same scikit-learn idea. I'm just taking that JSON input and turning that into something that can make these classifications. And again, if you draw more, then you can kind of see the different classes appear better. So for I got to scroll up to make it a bit more obvious. But so oddly, that's the red one. That's the blob over here, right? So oddly, yeah, that's the blob over there. All the points over here get a high probability value. You see that there's a couple of green ones here, but that's because it overlaps with this chin strap, with this other class. So if I go back up here, you'll notice that the blue and the green areas, they overlap at some point. So if points fall in the middle here, then I can't say it belongs to class A or B. It's probably 50-50 both. And that's what you see. That's what the classifier will do. Now, there's different ways of weighing this, right? But again, the whole point of this is that I make it easier for you to just put rules into your system to make it easier for you to benchmark. I want people to understand what the data is that they're dealing with. And I think it can be very helpful in the sort of the conversation of what model should go to production if you can actually benchmark it against human domain knowledge. I think that's something very, very valid about that. Human knowledge is probably not the thing that eventually will go to production, but just having this around, I think, is very healthy. So for these things, I've got this interactive classifier. I've also got this interactive outlier detector. But the bonus thing that I've got is it's also an interactive preprocessor. It might be that you're doing feature engineering. So what you can also do is you can say, well, let's load this data in. And let's not have labels attached. let's just say that I'm interested in doing an analysis in pandas, and I just want to select these points. I can do the same trick. I can have an interactive preprocessor. It accepts my chart data, and then I can use that inside of a pandas pipe function. Then I can say, okay, please give me like all the points that have been selected. Now get that attached. So you can actually make sort of a selection, just like the subset of your data in pandas, because everything's in the Jupyter Notebook, and it's super interactive, and it's amazing.
I'm like out of words.
Wait until you see the final demo, because it's going to get better. Because this is the end of part 1. But this is what I'm hoping to achieve with the human learn package, so to say. And again, this is something I made a couple of months ago. Super independently of this, a couple of colleagues of mine were doing a similar thing for Rasa. But I think like it's just a nice way to reason about things. That's the main conclusion that I've got, both in the situation for Rasa as well as for tabular data with scikit-learn. And we'll see later that this particular tool is also useful if you're going to be doing something with Rasa, and that has to do with data quality. We'll see, and I think you can imagine why that might be useful, but preview. Are there any questions about this before I move on to the next topic?
Let me check. They are basically asking which library. Yeah, like this library belongs to who? This library is made by Vincent himself.
Yes, me.
You
can pit install human learn, and then it should just work. There's a couple of weird things. So currently, so it's using bokeh under the hood, and bokeh has a couple of limitations. If you're running this on a not on port number 8888, but on port number 8889, then you have to give an extra setting because Jupyter security protocols otherwise start complaining. So there's a couple of like weird gimmicks with it. But definitely the documentation, human learn. I'll just put it into Google. It's like a pretty human learn coding GitHub. It's only a month. It's like only a month old. So you haven't indexed it yet. But this is the documentation page. If you go there, there's like proper documentations and stuff. There's a full video course that you can also follow. There's examples, there's the API guide, there's the getting started pages. Just check it out. Feedback is welcome. I hope it helps people.
The rules really help. Like at this point, I don't trust. Like if I have a chatbot, I wouldn't trust the chatbot to like respond, but like generate by itself, like a language model to generate response for a chatbot. So like these rules actually help with biases, or like this is the first thing that comes in my mind.
I think so. So you're right. The only thing I would say is even without the rule policy, which I'm about to explain, Rasa already puts a bit of a limit on this. So you have to define your actions up front. So a classification algorithm also has that property. Like you only predict these classes and none of the others. The downside of GPT-3, and if you Google the Rasa blog, you can find an article that I wrote. It's bad. Like it's no, it's like really hard to generate text from like if you ask GPT-3, could you describe a person, and you say, well, he's from Holland, it just generates stereotyped Dutch things. Same thing for German. I didn't try for Turkish, but it's really hard for it to generate something that's personal but not a stereotype. You don't want to have that in your digital assistant that's supposed to help people. That's not what you want. So
but putting, like for instance, like putting a human supervision plus GPT-2 or GPT-3 would be nice. But like we are doing all of this to get rid of human work. Like then what's the point? I mean. Like we can just write some utterances one by one as a response for our chatbots, or like we can actually combine like the generated stuff plus the rules that we make and like combine them together and make a reliable language model to respond.
Another thing that you can do is not worry too much about generating these training data, and instead just listen to what your clients are telling your chatbot and focus on that. That's seriously the main thing I always try to explain to people. Paraphrasing is good, right? Machine learning models doing a grid search, all that's great. The hard part of making a virtual assistant is understanding what your users want to use it for. Like I'm building a chatbot that's also a video game, so it's like a text-based adventure game.
The breakout one.
Yeah, so it's you have to pick up items and combine them, and it's a puzzle. But a dear colleague of mine started playing with it, and I was just curious how she would respond. But she never really played a video game before, but she had seen her boyfriend play video games, mainly Fallout and all these violent video games. So she thought that the point of the game was to break stuff. Like that was her impression. But my assistant had no way of understanding that because I didn't consider that people might want to break stuff in my video game. It's stuff like that, really. And also like all the different ways people are asking for help in that experience I hadn't considered. Like that's, I think, the best test to see whether or not something works. Like if you get happy customers from all sorts of places, then you're solving a really nice problem. I wouldn't be too worried about getting the best test result.
Oh, people ask can we access GPT-3 to test and play with it? No, unless you are granted access from OpenAI, plus you pay the money, I guess, right?
I think Microsoft has a deal with them nowadays. I don't know the full details of it. The only thing I can say about it is somebody gave me access to a key and I played around with it for a bit. That's
you can ask him GPT-3 questions if you want, but he will probably give you answers that I gave you earlier or something.
The thing so you can ask it questions, but you are not guaranteed to get answers that are factually correct. That's the main thing.
Yeah, actually, there is one thing people can sometimes miss in this topic. Generating language with some NLP models is some way it can be achieved or not, but our focus here is task-oriented digital assistance. We are not trying to develop a chatterbox to chat with you from anything. We are using these conversational AI, these chatbots, just as a user interface to make that computer do something we want. So it's sometimes irrelevant if you can generate some proper language or not, because that chatbot needs to do something for you, and it's usually it's not done with machine learning. You just code some basic programming, like mailing some text or querying a database or creating a record in that database. So the question whether to generate language with GPT-3 or some other models, I find it irrelevant in our context.
No, I would agree. Like, if you have a digital assistant where you can order a pizza, then you shouldn't need to worry about a user asking, "Hey, can you also generate a poem?" Like, no user will do that. It doesn't really belong to the use case. That said, though, some of you are probably thinking, like, what I just explained is nice, and we're talking about good things, but we should probably also talk about natural language a bit more in the context of virtual assistants. Basically what Yusuf just also did, like, hey, let's now take a step back again and really limit ourselves to what we're actually doing typically when we're designing a virtual assistant. I'm getting the impression that some of you are already familiar with Rasa, but I just want to maybe point out one specific thing that makes this problem interesting. When you have a conversation, and let's say we've got the human over here and we've got the virtual assistant on this side. Let's say the conversation goes something like, hey, and hello. Human says, I would like to have a pizza. Robot says, what kind of pizza? And then you can imagine that this is sort of the start of a form of some sort, or we're going into this avenue of the conversation. The problem is that the user can do something that interrupts this avenue. So you could say, for example, you're trying to order a pizza, but then halfway you're saying, oh, but by the way, are you a human? You definitely still want the assistant to be able to handle this question, but you also want it to be able to recover and go back to the conversation that was sort of started here. But that means that after every action, we might need to look back more than one time step in order to figure out what the next best action is. In order to know for sure what kind of pizza, that this was the correct response, we shouldn't look at what the user said before. We also need to see what the user said before that. So there's this time component to doing something with machine learning here, as opposed to just getting text in and then getting a class out. And it's this dialogue management, typically, that is the harder part of the problem. Going from a text like this and then understanding that we're trying to order a pizza and that's a class, that's relatively easy compared to, hey, where in this flow of the conversation should our attention go? That's typically the harder part of what we're doing here.
They're asking, don't we use form actions for this?
You could. So definitely you could. But it goes beyond forms. So in this particular case, you can say, hey, yeah, you're starting a form over here. But let's say you're not starting a form, but you still have I'll give an example in a moment. But in general, you have the situation where figuring out what to say here requires you to look back more than what you've just said. It doesn't just have to happen in a form. Also with intents, you sometimes need to know, am I in the beginning of the conversation or the end of the conversation? And that's what makes dialogue management very hard. The main observation here as well is that to handle this elegantly, we need to do something other than CSV files. So what I'm going to do now is I'm going to open up a Rasa project, and I'll show you something that's really hard about building good experiences.
Yay.
And one thing I would like to point out, it actually took me effort to break Rasa here. Like, it took me an afternoon to figure out a situation where it broke. But to introduce this first, the main way that Rasa works is by this notion of a story. And I'm using the new format. And the assistant that I have here is a little bit silly, but effectively what this assistant does is it can count. So what you can do is you can say, hey, the conversation starts, there's a greeting. Then the assistant has to say, oh, hello back. And then I can say start counting. And then the assistant should start at 10. Then if I say, okay, it should go to 9, to 8, to 7, to 6, etc. Like that's what the assistant is supposed to do. And in this example, I hope it's clear that in order to figure out here what you're supposed to be saying, you shouldn't just look back at what happened here. You also need to know what happened just a step before there. So there's this historical aspect. And I have an artificial data set here where this historical aspect is very, very important in order to do the job well. And what happens is the user can challenge the bot. So the user can say, hey, are you a human? And when that happens, first what needs to happen is, yes, I am not a human. But immediately after that, the assistant needs to continue counting. So 2 actions after each other need to happen here. That's the idea. Now, in Rasa, we have a component that deals with, I've got text coming in, and I would like to know what intent it is. It's the NLU part of our pipeline. That's the natural language understanding. So there's a system that tells us how to go from text to the intent. There's another system, though, that tells us how to go from the state of the conversation to the next action. So where, for example, greeting is an intent, saying hello back is an action that our chatbot needs to be able to do. So I think I've got a model pre-trained here, and let's just talk to it. So I've trained everything here up front, right? But just to give you an impression, I just tell it hello here. It says hey back, so well done. I can tell it to start counting. Okay, so it continues counting. I can say, are you a bot? It says, I'm not a bot. I'm a bot, not a human, powered by Rasa. It didn't really get it right here. That's probably because I don't have stories here. This is what it's supposed to do. It's supposed to at least recognize that it's also supposed to do a countdown right after it's been challenged for whether or not it's a human. There is, however, one problem with this, and I'll just restart the shell just to be safe. I'll explain what I'll explain what the issue is. It's always a shame when it doesn't go 100% the way I expect it to, but oh well. But here's the issue. So I think these stories are fine, right? I think I've defined a very good story here. But the problem here is that even though I've got this one example here where at some point we say goodbye and then the assistant is supposed to say goodbye back, notice that the examples that I have over here only have that happen after the very long conversation is over. So even if I have the smartest, biggest transformer architecture that will sort of try to look back intelligently, which, by the way, I do. We have a transformer architecture that's trying to properly do this. But even in such situations, it can be that our data set is simply too sparse for everything that can happen out there in the real world. And I hope you would agree that no matter what happens in the conversation, when a user says goodbye, we should say goodbye back. That's a rule that we can introduce. We don't need a machine learning algorithm to do that. And here the thing is, if I say hello, now goodbye. Oh wait, I should spell it correctly. That will help. Goodbye. Ah, okay. It says goodbye here. I kind of know why. The reason why is because I have a rule policy attached. This rule policy that's new in Rasa 2.0 that allows me to define rules up front like this. And it's a special sort of new syntax that we've introduced, but like the example that I had with scikit-learn, the idea basically is you can define a lot of rules here in your rules.yaml file. And these rules are usually very short parts of your story. We don't want to become a state machine, just like before. We would like to have this flow be relatively simple. But we can say, if the intent is goodbye, then no matter what we saw in the training data before, this has to be the correct response. No other thing could happen. This is the thing that must happen. And in this particular case, I'm being very simple because it's just intent and then immediately an action. But you can also get quite expressive here because we also allow for slots. You can even think like some of the stuff you would usually do with forms, you can also do this way, which means you can do things like, hey, if a user is in a form path, but this slot is not filled, then ask for clarification. These sorts of things that you can define, these are usually things that are really, really critical and also fairly easy to reason about. But these are now all things that you can say, well, those are now rules. And it's everything that doesn't fit those rules that we can still keep in these stories. And again, you have this nice little phenomenon where the easy cases can just be dealt with business logic. All the critical stuff can be dealt with business logic. For everything outside of that, that's where we're going to go and use transformers. And that's sort of the new path forward that we have in Rasa 2.0.
I was like, I just like got employed by some country, like by some company, like not in my country, like the United Kingdom. And they asked me to like make a chatbot with Rasa. You know, like I made a chatbot for them with Rasa, but like for 2.0, I was doing it with 2.0 and like I didn't have time to migrate it to 1 point something. I didn't train it enough, so the memorization didn't work, meaning that the stories weren't working. So like my bot was completely out of control. So then I have discovered that, yeah, there's a rule policy. Then I made my stories. I literally migrated my stories to rule policy because like I was literally pushing the end user to like comply with my rules. So like I've also sent them a demo of like, you know, how to like ask which questions, like how to ask which questions and everything to the bot, and it went fine. So it was like a savior for me for that moment. And, you know, I asked people over Rasa and they told me like, you didn't train it enough. you should be training it more and etc. Like I wasn't really tuning that well or something. I don't know.
So the hard part is, so the thing that makes this a really hard example to play with is I only have 4 stories in here. So if the entropy is just a little bit off, right, there's a lot of opportunity for bias. And that's also something that makes it hard to get started. It really works well if you actually have like tens of these stories at some point. Then there's a pattern you can actually learn. But especially if you're just starting out and you only have a couple of stories, and you have a lot of epochs over here, it's definitely a good thing that we have the memoization policy and the rule policy around, because then you can at least steer the conversation to always be something that you expect.
I find it like genius at this point. Like I really also like the diet classifier. Like I was hyped when it came out, like the diet classifier plus TED policy, more than I was hyped for 2.0 actually, because 2.0 was like UX and rules and stuff. But like when I read the paper of diet, I thought like, oh, that's awesome. Like that's literally something for chatbots.
Well, the main thing that I think is nice about the diet thing is that it's really customizable. So if you have Turkish embeddings, okay, that's fine. You can just plug them in, and like that is something that the research team also did spent a lot of effort on. And it's also, again, what I think is the goal. We're trying to make tools available such that you, the domain expert or the person at least closer to real life than we are, can actually make the decision and customize it to your liking. One thing to say about the data conversion and that sort of thing, you might already know about this, but we have this Rasa data convert command inside of the command line utils. And you can just say, well, here's my NLU file or my stories file, and this will migrate all of your data from 1.10 to 2.0 or whatever the version is that you're using. So if you're interested in porting your old 1.10 version to 2.0, this is just a one-liner that will fix most of it.
That's awesome. I didn't know about that. Most of the open source softwares don't really care about like how their users going to migrate.
We do. We really do.
Hard, like it's really hard to migrate, in my opinion, and like that's really cool.
So there's still things that you have to do manually, unfortunately. But this really helps. Like the migrating breakout bot was 15 minutes work because of this command, not hours, thankfully. But again, the main point here is at least that it's nice to these rules make it easy to reason about. Even if we have transformers, even if we have like very fancy TensorFlow tools at our disposal, it is nice to be able to constrain the model, so to say. That's the thing I want to say. We can do it here too. So, having said that,
the last demo is coming.
well, now I'm gonna start talking about some stuff that I'm working on.
Okay.
And I'm working on it, and I would love to get feedback on it. So, especially, I'm actually looking at Merve and Yusuf for this. I would love to hear if this is something that is useful, because one extra cool thing that we have at our disposal here, right? We can make business rules that use a machine learning model inside of it. That's also something that we can consider now. If we add a classifier to our pipeline that's just going to say, if I detect that somebody is swearing, then override whatever intent I have, and then the rule policy can pick that up and say, and therefore I'm always going to demonstrate this behavior. So just an idea, right? Something that you can maybe start thinking about. Something that I'm currently making for Rasa NLU examples is a language classifier. And the way that you're supposed to use it is as a fallback. If suppose that your intended language is Turkish and you notice that somebody is speaking not Turkish, then you can raise a message saying, just so you're aware, I only speak this one language. It's lovely that you speak French, but please convert to Turkish, otherwise I won't be able to speak to you. And again, this is very, very specific behavior, but if your users are confused about the language, this is something that can make the experience a lot better. And there's a similar thing happening with if people are cursing. Like at some point you can say, hey, that's something I don't want to have on my platform. So if you have your own specific model that's really tuned for that one use case, I think it will be nice to use a rule policy to bring those models into Rasa. Now, the hard part here, and I must stress this, and this is why these features are going to be experimental in the NLU examples library, is it can get hard to maintain. If you have, like, you might at some point get like 10 very specific models in your pipeline. And not only is that going to be heavy, like you're going to have to wait until the message gets back, but it can also be really hard to figure out what's happening. So I don't want to suggest that we should do everything using this technique, but there is a potential here. And that's something I'm actually quite excited about. Mainly because it means that if you have your own custom spacey model for this one use case you would just love to bring in, I might be able to make that possible in the near future.
I feel like normally, the policies have their own priorities and everything when deciding upon which action to take next. Like, for instance, like we have memorization policy, like we used to have other policies and they're now under rule policy. Like, how are you going to manage that this has the top priority or something? Like, because like it needs to be like on the top, right?
So
immediate action.
So the way the rule, there's a couple of things about the rule policy. If I'm not mistaken, you can set the priority between all of these policy mechanisms.
Yeah.
Please only do that if you know what you're doing. Like, I don't recommend people to do it.
It gets messed up a lot. Like previously, like when Yusuf and I were making workshops, we were talking about how to assign priorities, like different priorities to the default instead of default one. And I was like, I never do that.
I don't either. The idea is like.
By the way, I find the technique you are talking about, I find it quite useful. And just a quick idea of maybe we can even use some zero-shot models with NLI techniques to detect other language characteristics like positive, negative, or swearing words, or some other racist or sexist language beyond just recognizing the intent.
Yeah, so the one thing I do want to mention, detecting swearing is hard. Like it is actually, like, I thought it was going to be an easy problem. It turns out it's really, really hard. And the best example I have for this in English is if I go to someone and say, "You're a badass," I use the word bad, I use the word ass, but it's a compliment, right? So
yeah.
So definitely, I think you can do really cool stuff here. But you will need to check if this works for your specific use case and for your specific users. One thing about sentiment, though, because I've been thinking about that as well, it is just that these examples right here, these are all scenarios where you want to trigger a fallback. You want to overrule something because something is happening that you want to prevent. Sentiment, I can imagine at least, maybe that's better as a slot. Like as a value that's sort of long-lived in your conversation. And the nice thing about that is then you can maybe have custom actions that respond differently depending on what sentiment is currently in the conversation. It's slightly different than an intent. So that's definitely also on the roadmap. But there is this distinction between, do we want to have it as an intent, as a fallback, or a slot? And that's something I'm still trying to figure out as well.
Actually, instead of slot entities, I guess can work better because if we set it as slots, they will remain across the dialogue and affect other turns as well.
So, definitely true. So it will even influence TED. The TED policy also listens to the slots. So this is why this is going into the experimental bucket. So on the experimental repository, this is going into the experimental part of that library. But I think there's something here. And the main thing that I care about is that you can start playing with it. It's up to you to consider if you need it. And the main thing that I care about is that if you have this weird special use case, that it's relatively easy for you to build something custom inside of Rasa. Because I think customization is the best way to solve most problems.
So like the transformer model predicting, I think it falls under what Yusuf just said with, one-shot models, I guess, right?
Yeah, so I've never really done anything with one-shot learning, to be honest. If I'm completely honest, like it's completely new terrain and territory for me. So I don't want to promise anything on how good it might work, like because I have no experience in it.
I'm developing some zero-shot models for Turkish, and I find it sometimes better than just supervised training for text classification.
Okay.
So especially for detecting sentiments or topic discovery, or labeling sentences, some paragraphs for keyword or content detection, it can be easily achieved.
But you're using pre-trained models, I suppose, then, or you're training it from scratch?
I trained from scratch for Turkish. Yeah, because there are lots of pre-trained models for English, but in Turkish we don't. So I need to train it from scratch.
Someone has a question. What if we want to define that for a particular intent, there can be two types of actions that can be taken depending on the previous conversation? So how do you set that in the rule policy?
So one thing about the rule policy, one thing we don't want to have with the rule policy is that it becomes a giant... Oh, thanks. That makes it easier to read. What if we want to define it for a particular intent? There can be two types of actions that can be taken depending on the previous conversation. Right. So technically, you can use custom actions for this. Custom actions should be able to look further back into conversation. You can customize it as much as you like. One thing about the rules, though, there is a safety mechanism inside of it. And the safety mechanism does a couple of things. It checks whether or not there's a story that disagrees with one of your rules. If that's the case, the rule policy says, I'm not going to allow you to train because the stories have to be consistent with the rules. That also means that if there's ever two rules that are inconsistent with each other, that you're also going to get an error. Again, this is a safety mechanism. Another thing that's inside of it is that the rules cannot look back too much. Rules are meant for like small chunks of the conversation, because if the rules become very big, they also get very hard to reason about. Then you get this big nested tree structure that you're going to have to worry about. So you're allowed to have one intent inside of your rule policy, but you're not allowed to have multiple intents at what per rule. And that's a safety mechanism to prevent this whole system from blowing up. That's the idea.
So another question, not to you, but I can also answer. So they're asking, what is Rasa's exact product? What Rasa create? This kind of library or some sort of software for programmers to use? Rasa is basically a chatbot framework that you easily create a chatbot out of. And we have given 4 weeks of workshop on Rasa. For some reason, I can't post anything. Somebody else was also asking about your library's GitHub page. I tried to post stuff, but currently I can't post anything. So
it's going to be on the screen in a moment because we're going to the last demo of today.
Okay. So if you also if you want to learn Rasa and you know how to make chatbots, chatbot from scratch, you can head to TensorFlow Turkey, and then there is a whole hands-on Rasa series that you can somehow binge watch.
and over at the Rasa YouTube channel, we're also making tons of seasons. So binge watch is definitely the key word. But
apart from I'm so sorry, Vincent has an awesome Vincent creates awesome videos called Rasa Algorithm Whiteboard, which explains transformer architecture and everything very in a clear and intuitive way. So do watch it. It's really great. Yeah, that's a promotion.
Yeah, thanks. It's definitely the most after Diet, the Transformer videos are easily the most popular videos that I've made. I think we're nearing the stage where like the algorithms that we make have like 3,000 views or something, but those transformer videos are now getting like 5,000-ish or something. So like it's almost the case that somebody else's algorithm is more popular on my channel than our own. But if it helps you people understand what we're doing, that's great.
What are you working on?
So this is something that I was working on today, and hopefully it's a cool demo, because it's also live as of today. So let's talk about my job. So, what is it that I do? Well, I kind of try to make sure that the community around me is able to do good things in the entire pipeline. Let's say it's general machine learning, but specifically about Rasa as well. You start with your data, you do your analysis, you pre-process, you model, and then you got this production step, so to say. But one of the things that is starting to bother me a little bit is that whenever you read articles or whenever you look on the blogosphere, it seems like there's many opinions on how to do this modeling bit and this analysis bit and this production bit. But all the stories that you hear always seem to be about English. And I've got reasons to believe that maybe literally the results from English don't necessarily translate. Like, it doesn't really, I think English linguistically is a very easy language if you consider the grammar. It's an apple. If you consider German, you have die, dem, der, das. It's really unclear how, there's more grammar rules to be had there. Like the language itself is relatively simple. And I'm not really familiar with Turkish, but I can definitely imagine that the grammar is just different, for example. So many other things.
Turkish is super hard, like so hard.
It's a highly inflectional language, so any word can get many suffixes. So it makes it quite challenging to deal with in NLP.
Are there so lemmatization and stemming tools? Are those available for Turkish?
Yeah, there are some morphological analysis tools or lemmatization stem analysis tools. There are some implementations. Yeah, but the issue here is, for example, when you tokenize a sentence in Turkish, you get a stem and lots of suffixes.
Mm-hmm.
So it increases the number of tokens in any NLP model.
So one thing I would like to mention there, maybe, and I'm actually very happy I asked this, I have added this stanza library to Rasa NLU examples. I could be wrong, but I believe Turkish is in there. And one of the nice things about that tokenizer, it also features lemmatization. So, and that lemmatization can be picked up by the count vectorizer inside of Rasa. So that way we don't have a sparse vector with a unique ID for every single word. We look at this shortened word, and that's the thing that we add a feature for.
Yeah. Actually, I haven't played with stanza very much, but in our chatbot in Turkish, I'm using Zemberek NLP, which is a Python package.
Could you spell that?
For Turkish NLP. It's ZEMB EREK. So it's specifically a Turkish NLP package.
Did I spell it correctly?
There is an E instead of A.
Zemberek.
Zemberek, yeah.
Okay. I'm putting this.
Yeah,
I'm immediately putting this on my to-do list.
Implemented, so it has a Docker package for as a gRPC server, and I wrote some Python client code and just integrated it as a Rasa component. So basically, it can do some noisy text normalization, some tokenization, lemmatization, and other morphological analysis.
Is it open source?
Actually, it's not that. I can make it open source. I use it in my chatbot, but maybe I need to document it for use by others.
So I just added an issue on Rasa NLU examples. The issue is titled Zamberic, and the text that I wrote down is note to self, learn if I can edit here.
Yeah,
if you need help with documentation.
Maybe I can push some example that repo with Zamberic.
Please do. From Turkey Turkey meetup, let's investigate if we can add it here. So I've just made a note there. Feel free to log in and let something know. I seriously wouldn't mind helping with some documentation and maybe some code cleaning. I would love to put this out there for other Rasa users.
Yeah, great.
But this is nice because this is exactly the point that I'm trying to sort of do. My goal this quarter is to speak more about non-English around. So this is a nice one because this is a big one. But it's not the only thing that I'm worried about though in this whole entire pipeline. I can make embeddings available, and I have done that. But there's something else that's also an issue. Wait, and then I need to so many shortcuts. My bad. Let's go back here. Yes. Because another thing that I wonder about is we have this predefined pipeline, but if this is set in stone, it's also kind of hard to customize, right? And it's also really hard to customize if people don't really understand all of these separate components, because it is complex. Learning Rasa, especially if you intend to make your own NLP pipeline parts, it takes a while to fully grasp. So part of what I'm doing is this algorithm whiteboard. I'm really doing my best to make sure people understand how some of these components work. But instead of maybe talking about how these components work internally, I'm kind of wondering, can I maybe not just make more tools to just make this more fun, to make this more easy? So what I've been doing is I've also been maintaining this library called What Lies. What it does is it easily allows you to play around with any sort of embeddings. It's scikit-learn compatible, so that means that if you found embeddings that you like, you can immediately click it into a scikit-learn pipeline. But I currently support TensorFlow Hub, Hugging Face, sentence transformers, byte pair embeddings, fast text. And as of today, I've also added the sentence transformers that under the hood use Hugging Face, and there's also some Turkish models there that are supported. But the goal is that it's really easy for you to visualize and to sort of analyze properties of word embeddings. It's something that we do there. I've talked about Rasa NLU examples plenty. One thing I would like to maybe add there is that we also try to make it easy to train your own embeddings. So if you're training on the open subtitles data set, that's something that we can maybe make easier for you as well. But maybe if I have a look at this pipeline, all of those tools are nice, but they're not the thing that we should be paying attention to. Because if I look at this giant pipeline, and if I compare that to the blogosphere, then I would argue that probably what gets the most attention is this stuff. Because this stuff requires GPUs, right? And it requires the big, heavy model. And the stuff that doesn't get as much attention, but might be more important, is actually all the stuff that happens on the other side of the spectrum. And I think the reason why there's this sort of gap between what's important and what people spend attention to, I only now realize that attention has a double meaning, but okay.
Unintended pun.
Yeah, there was an unintended one. It also happens. But I think the better way to look at it is to not see it as a pipeline that goes from left to right, but to look at it as like a stack that builds on top of each other. Because let's be honest, you can be great at this part, but that's not going to save you if you're bad at doing this part. right? I mean, if you have pre-trained models that have bias in them and you want to remove that bias, the only way to save you is to have good labels. So before I thought, oh, I can really help people out by focusing on this part. I'll just make all of those language tools available and that'll help people. And I think it's good I did that. I think I'm actually helping people by doing this. But maybe one thing that's missing is making this part easier. Because maybe we shouldn't be paying too much attention to this. If I've learned anything from the rule-based policies, is that we can make an easy improvement by just sticking to our gut feeling and by putting something more human into the system. And there might be a wonderful opportunity to do the same thing here. So now I'm going to give the demo that's going to combine everything that I've been talking about. What I've got here is a Streamlit app. You might have seen Streamlit before. But this is part of a different open source project that I'm building that's called Rasa Lit. It's a collection of Streamlit apps that are supposed to make it more fun and easy for you to work with Rasa. So think like interactive components and things that look pretty, effectively is what I do. Now, what this thing is able to do is you're able to give it a text file. And then what it's going to do is it's going to take all of your text. It's going to pass all of it through the universal sentence encoder. And then it's going to try to cluster it. So what I've done is I've taken some data from the standard Rasa demo. And I just figured, hey, let's cluster it and see if we can get pretty clusters to appear. Now, hover over here. There's some settings here, but let's just zoom in instead. I think people like it if they can see things. Oh, and by the way, I can totally zoom in and out here. That's like a feature that I can also do.
By the way, someone is currently asking about using word embeddings for generative adversarial networks, and you are currently showing embeddings, right? So that actually are these embeddings?
Yeah, so we're looking at embeddings. That's definitely true. I haven't really done anything adversarial with embeddings in text, so I wouldn't be able to advise on that. I'm sorry, I've never done that.
Me neither, but he is asking how can I learn word embeddings? Where can I learn them? Could you give any advice? Currently, he's actually showing word embeddings.
Right. So there's a YouTube channel called The Algorithm Whiteboard that I think should be good. On the algorithm whiteboard, I start with letter embeddings. You'll literally see me build the algorithm to train an embedding for different letters of the alphabet. And from there, I basically explain all the different word embeddings that I currently have in the Rasa NLU examples repo. That should be a pretty good introduction if you're interested in this, especially if you're interested in maybe applying this in the Rasa setting.
Also, his project, he talked about what lies is all about what lies in the word embedding. So,
yeah, that's where the name came from.
Word embeddings. What lies.rasa.com, I guess, right?
From the top of my head, rasahq.github.io/rasahq/what lies. I think if you just type what lies Rasa, you should be able to find it.
Yeah. Anyway.
Here's the thing that I find interesting about this phenomenon, though. So I'm using UMAP, and UMAP is an amazing dimensionality reduction technique. It is really amazing. It's always doing a great job of just getting the clusters that I like. But what's amazing to me is you can just hover here, and you can see that there's a cluster here that's all about asking for jokes. And it's natural. There's no labeling happening here. This is totally unsupervised, but there's a cluster here with just jokes. And here there's a cluster that's about restaurants. And here's a cluster of people being mean. There's a bunch of these things. And again, I must stress, this is untrained, unsupervised. I'm taking a pre-trained contextualized embedding, something like BERT, Universal Sentence Encoder, passing my examples in, and it's able to cluster it up this way. And I think this is super useful because let's think about the starting point for a lot of people who make digital assistants. You probably have a feed from social media, people's opinions on how well your service is. And, you have some text that you can start with, but you probably don't know what intents to use just yet. But you typically have this big file that just has examples of people on social media talking to you. And there should be relevant information in that. So wouldn't it be nice if you can just say, look, take your big text file, repeat this whole thing, but on a Turkish embedding or whatever embedding that you prefer, it wouldn't be nice if you can just say, let's click around here with a polygon, and then we can sort of check if everything in there is the same class, and then immediately attach a label. So if you go to the Rasa Lit repository as of today, you'll find the app you just saw and this one notebook. It is Vincent's bulk labeling hack. The notebook basically step for step tells you how to use it. It's combining the human learn package as well as the embedding package that I currently maintain. And I'll just quickly go through the basics of what we're doing. The main thing here is I'm saying, look, let's import some embeddings that we like. I'm downloading the byte pair one. There's a Hugging Face one. There's universal sentence encoder. Then I'm loading up my text file. And then one thing that you can do is you can make these plots like I showed before, but you can do it for different kinds of embeddings. So you can sort of say, well, you know, the byte pair language one is already better than the count vector one, but it looks like maybe the TensorFlow Hub one is better than the Hugging Face one. You can sort of pick whatever embedding you think is best as far as the clustering goes. You can tune it. But once you're happy, what you can do is you can maybe, let's run this one more time. That's the downside of UMAP. It is a little bit slow. But I do want to have this demo go amazing, so I'm just going to wait this one out.
In like we have this, there's this guy called Refik Anadol, and he makes awesome data sculptures. And recently, normally he uses VGG with GANs, but currently, like, he made this data sculpture out of word embeddings of Renaissance poetry using UMAP. By the way, that's awesome. I already sent you.
That's the
there. Yeah.
That was the, so it was also UMAP. That's nice. UMAP is amazing. Like,
yeah,
I need to like have a drink with the person who made it. It's really great. But anyway, this thing loaded. So here's what you can do now. You can just say, look, let's just select this cluster over here. I'll just scroll down. And using this interactive preprocessor that I showed you earlier, I can just have a look at what we've got. And just looking at this is all about time. If I look at what I've selected. So I can just say, you know what? All of that is about time. Okay, time. Let's label that. We just assigned 51 labels in about 10 seconds. If I now scroll up and if I now rerun this, that cluster is now gone because it's already labeled. And I can move on to the next cluster. And this one's about restaurants, so I can just say restaurant. All right, 55 labels, nice. I think this took about 20 seconds in total, and we now have 100 labels already. I'm not going to do the whole data set, but what I had, like rough estimate, I do about 1,000 data points per 5 minutes if I do it this way. Now, again, I must stress this, and I actually wrote it down because these points are important. This method of labeling is great when you're working on version 0 of something, right? I don't want to suggest that this is very high quality labels, but as a starting point, one thing that's amazing about this one particular flow is I don't have to tell you what embeddings to use. You can just go ahead and use whatever embedding you like and whatever dimensionality reduction technique that you like, and this should make it much easier for you to just get started. And this is what I think is going to be super interesting, to make more of these sorts of tools available. So this is what I'm working on. This is what I'm trying to do more of. And I think making stuff like this is going to make it easier for people to do non-English than to only concern myself with embeddings. I think embeddings can be useful if they're pre-trained. That's great. But I'm trying to make this phase easier as well.
That's awesome. Like I was like, it is one of my thoughts. It is probably done, but like I was wondering if, you know, there are people whose job is literally to annotate data. Maybe I thought like maybe they're actually firstly clustering data, and then, you know, like people can, you know, annotate this data with clusters. So this is literally the idea, like the concrete version of the idea. That's like with embeddings. I was talking by means of computer vision or something, you know. They should have been like clusters.
So I've been told there's a computer. I've been told that in computer vision, there's companies that offer this as a software. So that's something I happen to know. This is free. Just wanted to mention that. You just don't need to pay me for it. What I do know as far as labeling goes, there's two things I do know that might be worth sharing. Because there are lots of companies where you can go and do labeling. I know of one company in the Netherlands, and they do something that's actually quite cool. They have people on the spectrum of autism, and what they're trying to do is get like good work for them. And if you have autism, then not every work environment is going to be great for you. You want to have a work environment that's very predictable. Like these are things that you typically like. Turns out that labeling is really predictable as far as work goes, right? And the thing is, you have people who like doing this kind of work because it makes them more calm. So your label quality will go up if you go with these sorts of companies for this sort of thing. Now, other companies like to sometimes also use Mechanical Turk, I think is the name of the service. It's something that Amazon hosts. So the thing at Rasa, I do know, I've heard stories of people using it. The only feedback I have, if you're going to go down that route, is you have to be careful that you want the task to remain fun in some way, simply because otherwise the quality of the labels goes down. If you have, let's say, 100 people that have no idea how you're going to be applying your data, they just have to say, well, is it yes or no? Well, they're not going to have as much attention for it. So even if you can outsource your data labeling, one thing to be really careful about is that the quality of the labeling might not be exactly as you would like. It's just a fact of life. You have to be really mindful of that fact, which is why I usually prefer just label my own data, if I'm being completely honest.
So a question. This is brilliant, Vincent. Yay. Agreed.
That's not a question.
Okay, fine. Yeah, let me show myself. It's brilliant, Vincent. But in case of too many overlapping clusters intents, how would you handle this?
So let's do that, shall we? Let's remove that one. Let's actually zoom in. Let's see if we can zoom in here.
Can't you just, I don't, oh, they are not colored because they are not supervised like they're.
So
right.
These are not colored because it's indeed unsupervised. So one thing that you can do, so if there's overlap, right, one thing that you can do is just not label it. That's like one thing that you can do. Only label the stuff that's like really different from each other. Another thing that you can do, I mean, let's say that, I don't know, let's say that you have a lot of conversation that's chit-chat and frequently asked questions, and those are relatively easy. But let's say that there's another one that's a little bit more hard. Let's say you have lots of questions about something that's specific. What you can also do is you can just first remove all the easy ones. Let's make sure you've got those. And then you can say, well, the remaining clusters that I have, let's just UMap that single cluster once more, because maybe UMap can do something that's a little bit more clever to split those up. That's also something that might happen. But the goal here is that you are more quickly able to label the easy cases. That's what we're doing here. If it's very overlapping, then it's much harder. So in that case, you can also just say, well, those are harder to label. I'll save those for later. I'm not suggesting it's perfect.
Like, you know, sorry? Like if two intents are actually overlapping, there maybe is a reason. Like maybe like in Rasa there are multiple intents. Like when you say no, thank you, there are actually two intents there. One is like negative, and the other one is thanks, for instance. And maybe like, you know, that sentence falls under like close to somewhere between the embeddings of no and embeddings of thanks, right? So it may be the reason why it falls under there.
It's either way, it's still hard. Like that's the
we are not that easy as humans. Like we don't really say one thing in one sentence. That's why like we are very complicated. That's why AI can't solve everything.
So one thing that I can do now real quick is it says, hello, what can you do for me? What can you do for me? And there's also show me a restaurants here. So this cluster is probably built up of like other clusters. So one thing I can maybe do is just maybe move that over here, see if we get something else. Are you okay? What's up, man? Okay, so like if you were to zoom out over here, right? You might be thinking, hey, this might be one cluster. But one thing you can always do is just zoom in and see if that's actually the case. That's something you'll have to do manually still. But again, the goal here is that this is your first order label. I think the main thing that might go wrong here, actually, now that I think of it, suppose that you take your customer reviews as like your training basis for your digital assistant. That's fair. I mean, it's like valid feedback from users. But the way that people are going to be talking in a review is different than the way that they'll be talking to your virtual assistant. So therefore, yes, you might have a good starting point, and yes, it's a fair proxy, but odds are you're probably going to be iterating on your data a whole lot as you're building your virtual assistant. If I've learned anything about this field, you're probably going to iterate more on your data than on your model.
Also, like, can we entertain some NLP related questions? Because like Yusuf and I are like one of the few NLP people in Turkey that actually do streams and everything. So they are basically always asking their questions to us. Maybe they got bored or something, and maybe they want different answers. So you can ask questions about language models, because like there's a different perspective in here. Maybe about GPT-3. Like people really love asking questions about GPT-3. You can ask questions about it. Yeah,
I mean, the answer for GPT-3 is always the same. Just be careful. Like that's the main thing I have to say about it. There's impressive parts, sure, but be careful. That's the main thing. But I guess the main question I have for people in the audience, I guess, like that's the main thing. The reason why I'm here as well. Hopefully I've presented some things that you are able to use. So the What Lies library, I really do my best to make sure that it's supporting lots and lots of languages. If there are things that you would love to have inside of Rasa that currently don't exist, like the Zemberg, what we just discussed, let me know. Like a big reason why some of those things aren't implemented yet is because I don't know about them yet. If I do, I can take some time to actually make that easier for you. Please let me know. That's the main thing I just want to leave people with. It's my job to make these tools for you. So please tell me what to do.
Like you are really creative, in my opinion. Like all of these libraries and everything, like you ask some solid questions and a library comes after it. So I really admire you a lot.
Thanks, but don't admire me too much. I think we just found a bug. Okay.
So it says like Prasoon, I guess that's how it's spelled. It's not Turkish. Asks, what is the state of long and short-term attention-based model in NLP and Rasa implementation? I think long and short-term attention is really critical for NLU.
Yeah. I have to admit that I'm maybe not 100% familiar what you're referring to exactly, but there is one thing that we should observe. If I think about the NLU part, which is the part that says I got text and I need to translate that to intents and entities, the sentences that we receive inside of Rasa are relatively short. We typically don't have long contracts of text that we're parsing over. We're not dealing with books. We're dealing with sentences, and short ones at that. I can definitely imagine long and short term being more of a theme if you have very long texts, but especially if you have an assistant where you might get at most 5 words, I can imagine that the effect of having super long term and short term attention is a little bit less relevant. Now, if we think about the core model, which is how do we deal with the story and how do we pick the next best action, then we do have maybe more happening there. But there the problem also is a little bit that you don't want your attention mechanism to span too much, because it is a small constraint on your resources as well. That's the most I can tell you right now. Sorry, I'm not super familiar with the long and short term latest research in that sense. But this is something I I don't think it's going to be mega relevant considering we have very, very short sentences usually.
There are like on papers with code, there are pages dedicated for tasks, like for instance glue or like cola or like I don't know which one for NLU, but they always have this leaderboard where like the first one is the one with the most accuracy. So I think they can actually go check out which one actually is a state of art at this point.
Could be, yeah. So could be. It's just that what we try to focus on first. So there's a couple of things that people are working on internally, but the main thing that we are trying to focus on is that's sort of a must for all of our algorithms. They have to be customizable. So we have to be very careful that we don't pick a model that has like the state of the art, but only on English, because that's a big risk for us. We want to make sure. So some of the time that our researchers spent is just whenever there's a new data set available, we have to benchmark diet against a non-English text. Like I have a researcher who spent like a couple of weeks just collecting data sets that were non-English just to make sure that diet was robust against them. Not necessarily state of the art, but that's because what we're trying to do is not necessarily be state of the art on a specific task. We're trying to be customizable for the general population of planet Earth.
Yeah, like there was a use case. I think it's N26, the app name. Like they have made this representation of the intents and actions in stories. It's a banking app, by the way, and
yeah, I know them.
Like applicable to every single language. Like I thought that was genius.
They kind of built their own CMS around it. That was actually kind of a flex what they showed there.
I feel like intent recognition and entity recognition and itself should be a separate task rather than natural language understanding, because there is a little spoken language. Does it fall under spoken language, by the way? But like it is complicated. Like it needs its own task and its own leaderboard, in my opinion.
So the weird thing with some of those leaderboards is that what I've done a couple of days ago is I trained my own embeddings on the open subtitles dataset, and I figured that should be better than Wikipedia. Because obviously, if I take the Rasa demo bot, if I look at the conversations people have with it, I think Wikipedia is a bit too formal. It's past tense, and if I read Wikipedia, that's not how people talk. Like I've never seen. You don't see two people in an elevator and go, "Julius Caesar was born on." Like that's not really how the conversation goes. I think. I don't know. I think that the whole world doesn't behave that way. So anyway, Wikipedia might have some information about how language is used, but I think having a data set that's more conversational is probably better. So I benchmarked it on a hard variant of our Rasa demo bot. I removed the response selector to make it like a hard task, and then it turned out that my own pre-trained embeddings were causing a 1% uplift in intent detection over sparse features and nothing else. And then I benchmarked all the other embeddings that I had, and then it turned out that my embedding was actually still the best one, but they barely caused like a 1 to 1. They barely caused more than 1, maybe 1.5% uplift. So again, I basically wasted a whole lot of time training my own embeddings. I should have just focused on the labels first. I think that would have been a more effective way to spend my time. I don't know though, and that's the thing that I find interesting. So I think it's a valid experiment, but this was just for English. It might be the case that this is different than if you're doing this in Turkish, for example, or you're always solving a very specific problem. That's the main thing I'm trying to say here, I guess.
Like I'm mostly I'm not an academics kind of person, so I'm not really experimenting much. I will be in a year because that will be the last year of my master's. I'm also looking for a nice question to ask, so I feel like it will be probably about Turkish NLP, and if I come up with a nice tool, I will let you guys know it. So if we don't have any more questions and you don't have anything to tell, there's a phrase in Turkish called like olaysız da alabiliriz. How can we translate it? Yusuf Hocam. By the way, Hocam basically means like he's my, like some sort of a mentor for me. Like, so it's like a mentor, teacher, and everything. It's Hocam.
Okay.
And yeah, I get it as a praise. Thank you. So, it's a joke actually among young people to mean like let's go without any extra trouble.
Yeah, that's
my best translation.
We've caused enough trouble. Let's just stop here, kind of like that.
Yeah.
He's a linguist, by the way. Like he's literally a linguist. So that makes him like a computational linguist, I guess. Like he can code. Yeah.
So the funniest thing that I've ever told a linguist was the sentence, "Hey, let's talk about conversations." There's actually kind of a lot. I will say that's kind of I guess I could have expected that, and I should have expected that, but I didn't. But now I work at Rasa. We actually have a couple of linguists as well. So the research team obviously should have a few linguists, but there's actually a niche of people who do linguistics on the side, and like we have a lot of those at Rasa. I will say that working at Rasa definitely makes me appreciate language way more than I did before working at Rasa. Just simply because you're so much aware of all the angles that language has, which I wasn't too aware of before.
Me too. Like it's not like I'm working in Rasa or anything, but like yeah.
And if anyone here listening is thinking, hey, I want to go into NLP and they're in college, I would like to maybe give you one bit of advice. You might think that you have to learn everything about deep learning because that's what all the blogs tell you. But let me tell you that once you're graduated and you don't have access to, linguistics professors around you anymore, there are way more blogs about deep learning bits, and there's not that many really great blogs about the linguistic bits that are relevant to the field. So if you have an opportunity to study linguistics while you're still in college, take that opportunity. It's something I've noticed that I'm missing, and it's quite hard outside of academia to really study it yourself. Like deep learning stuff is easier to read a blog on and sort of familiarize yourself with. But there is something there that if you're doubting, take the linguistics class.
Yeah, thank you very much for this comment, actually. I'm using this website called Curious Cat to answer questions about AI and NLP. And I frequently get questions like, I'm studying linguistics, or I'm studying some Turkish studies, some kind of Turkish studies. How can I start with NLP or AI in general? Usually I give an example from myself. I personally studied linguistics at university, and also translation studies. My master's degree was also in translation studies, and my thesis was in machine translation. So as long as you study linguistics or language-related fields such as translation or language studies, anything else, you can easily jump to NLP because you will need that knowledge.
So I think you can still get a long way without it, but you hit a ceiling. That's the main way I experience it. Like you can always call fit predict. Like that's the easy part. I think you don't need a linguistics degree in that. But things like Zipf's law and like how does the tree that's behind the sentence, the grammar structure there, just being a bit more aware of that. I do not. That's something that I'm currently missing, and I think it's harder for me to pick that up simply because I don't have like I have researchers around me, but like there's not that many books. You need to talk about this to really get it into your head. But yeah.
We have a question. Is indirect sentiment analysis popular nowadays? Is WordNet being used for different languages? Which one of you can answer this?
I think Yusuf should be able to answer that. But WordNet seems... WordNet is still used, right? I know in English it is. I don't know about Turkish, but WordNet I think is still pretty useful. Yusuf?
Yeah. Sorry, I couldn't get the question.
Is indirect sentiment analysis popular nowadays? Is WordNet being used for different languages? Someone asked.
Yeah, actually, in my experience, I usually find WordNet less and less frequently used in production pipelines. Yeah, in academic papers, it is used to benchmark some techniques, but in production, in real-world examples, I find it quite less frequently used when compared to the past.
That could be. Like the main thing why I think WordNet is still being used is I sometimes still see papers with WordNet in it, and I only learned about WordNet when I started joining Rasa because that's when I started reading all these research papers. So to me, it was like, oh, it's like super new, but it might be because I only started reading them 9 months ago. But that might be valid actually.
Yeah. By the way, like someday, if after the COVID ends, we would love to like have you in Turkey somehow, and I will send you Turkish delights, and separately for the office of Rasa, another pack of Turkish delights. Thank you so much for like.
No worries.
Thank you very much, Vincent, for joining us and sharing your experience with us.
No worries, my pleasure. And one thing about the Turkish delights, like, like basically what happened there is I think Thomas picked up that I was speaking here. Then he asked about Turkish delight. Like on Slack, he kind of cut me. He said, "Oh, Vincent, you might be causing Turkish delight." Well done. Like, he's happy I'm speaking, but he's really happy about the Turkish delights, I think.
Yeah, I think so. But like, I mean, no worries. Like, also send me your address so that I can send you one separately because, like, I think that you work remotely, right?
Yeah, no, but we talked about this. Like, I'll send some stroopwafels that way. If you send me some Turkish delights, it'll be like a fair transaction. That'll be great.
Yeah, that's a fair exchange. So, olaysız dağılabiliriz, I guess.
Yeah.
Thank you so much.
So, thank you very much for joining us today. This video will remain at our YouTube channel. So if you missed some parts, or if you want to rewatch it again, so you can just go to our YouTube channel and watch it anytime. And thank you both, Merve and Vincent. It's a great pleasure to have you here tonight. I think it was a quite fruitful meetup for our viewers as well.
See ya.
Ciao.
Bye-bye.
Yeah, see you.